Welcome everyone, and thank you for joining us today on the first of our 3 sessions around controlled environment agriculture. So today's session is the role of CEA in the sustainability of the agricultural sector. So as with all of our events, I need to do a quick mandatory disclaimer, and then we'll get on with the exciting stuff talking about CEA. So today we have asked Richard Glass from CHAP, Crop Health and Protection, and Alex Giles from Liberty Produce to join us to provide us some tips and tricks on the role of CEA, or controlled environment agriculture, in regards to the sustainability of the agricultural sector. So the topics discussed today are an overview of options for you to think about and to help you with your independent research and business decisions. So they aren't intended as recommendations or advice. Please remember as well that your business has its own individual circumstances, so the statements and views expressed may not be applicable for your business. So as I said, my name is Wendy Hewitson, and I am the Eagle Labs AgriTech Program Manager. So I'm going to give you just first off a quick overview of what is Barclays Eagle Labs and what do we do, and then why we're looking at AgriTech, and then of course around controlled environment agriculture. So Barclays operates the UK's largest network of business incubators. Eagle Labs and the international fintech experts RISE. So we have a compliant community of over 650 technology startups that are connected globally across 29 locations. So in the UK, 26 of those sites, and they are based from Guernsey and Jersey, right down in the south, all the way up to Aberdeen in the north in Scotland. And over the last 12 months, we have done 3,250 events with over 120,000 event attendees. So hopefully from today's session and the future sessions, you'll really enjoy what we're talking about. So as I said, I am from the AgriTech vertical within Eagle Labs, and our vision is to accelerate those UK agricultural industry to adopt and look at emerging technologies to increase efficiencies across the food supply chain from field to fork. So that's from growing more food with less resources, perhaps the use of robotics for planting and picking, or demonstrating how AI can improve resilience. We are about empowering the industry to make better decisions on how to improve their business both now and for the future. So the AgriTech Eagle Labs program is tailored specifically to support those AgriTech businesses by giving them access to our Eagle Labs network and the opportunities that it brings. We also launched our Eagle Lab Farm in partnership with the University of Lincoln in October. And this is a really, really exciting opportunity for us to showcase what we can do and how AgriTech can work in cooperation with ourselves at Eagle Labs. So let's talk about AgriTech, let's talk about why we're here. So there have been some headlines out there that the world's population is expected to increase by another 2 billion in the next 30 years. So from around about 7.7 billion to 9.7 billion in the year 2050. And that is estimated to require an additional 60 to 70% more food. It also has an implication on environment. So these environmental implications or challenges are real. So the water wasted in food that is never eaten is equal to the water needs of Africa. And the CO2 emissions are equivalent to removing every car off the road across the world. Reality is that roughly 1/3 of the food produced in the world for human consumption every year, that's approximately 1.3 billion tons, gets lost or wasted. So it's understood the food industry faces enormous systemic challenges, and further expansion of agriculture is not a viable solution to meeting its future needs, because we're using nearly all of the land that's suitable for agriculture already. So AgriTech, it's the use of technology and technological innovation to improve the efficiency and output of agriculture. It is the application of technology to improve all of these elements of the farming and growing processes, whether that be IoT, whether, as I said, that's AI robotics, precision farming, alternative proteins, or what we're looking at today, which is vertical farming and controlled environment agriculture. So an overview, I think you'll probably know this already, but controlled environment agriculture is a technology-based approach to food production, and its goal is to circumvent and minimise factors such as seasonal, unpredictable weather, and to encourage environmentally friendly food production systems and provide a year-round, high-quality crop production system that is traceable throughout the whole production chain. Plants are often grown in this method using hydroponics in order to supply the proper amounts of water and nutrients to the root zone. CEA optimizes the uses of these resources, such as water, energy, space, capital, and labour. CEA technologies also include aeroponics, aquaponics, and aquaculture. So vertical farming has the ability to produce crops all year round, as it says, in a controlled environment, with the possibility of increased yield by adjusting the amount of carbon and nutrients the plants receive. Also to consider is urban agriculture, where controlled environment agriculture can exist in hand inside buildings that are already existing and can be in repurposed abandoned buildings. So we're really privileged today to have some of those experts join us, where they can tell you more about the research and development being done in this fascinating area, and also hear about some of the new businesses and business models that are emerging into the marketplace. So as I said, this is our first session, and we have Richard Glass from CHAP, whose presentation is covering the role of CEA and the research being undertaken across their sites. So I'll hand over to Richard in a minute, and then we'll listen to Alex Giles from Liberty Produce, who's looking at the future of TCEA beyond microgreens. So you've heard enough from myself. Let's hand over now to Richard from CHAP. Hi, Richard. How are you today?
Very well, thanks.
Good, good. I'm really looking forward to finding out what work CHAP has been involved in this exciting area. So if you'd like to do your presentation, Richard, I'll listen, keep my 2 ears open and my 1 mouth shut.
So I'm Richard Glass. I work in the innovation team at CHAP, which is based at Sandhutton near York. And CHAP is one of the 4 UK AgriTech centres, and we have a number of facilities around the UK. And some of those involve the use of controlled environment agriculture. We have Liberty Produce, based at the James Hutton Institute in Dundee. And near York, we have Stockbridge Technology Centre, where we have both greenhouses and vertical farming. And at Warwick, we have another greenhouse with a novel construction technique. So at Stockbridge Technology Centre, then we have a modern glasshouse, which is being built to look at trying to develop a new biopesticides with a way of controlling the spread of any spores or insects between different plots. We can separate out 12 different bays within that greenhouse to allow better testing of biopesticides. Within the greenhouse in general, we can look at different IPM techniques, and we can look at using different types of growing media, irrigation techniques, biostimulants, different types of fertilizer, to see how well they work in the different environments with the different crops. We also have deep water hydroponic tanks, which you can see on the right there. This is a trial that we did looking at lettuce. And there you can see just how deep those tanks are, and the roots on the right-hand side growing into the hydroponic system. At the James Hutton Institute, then we have the Liberty Innovation Hub for Controlled Environment Agriculture at the bottom there, which Alex will go into more detail about. But this is really a container-based system that we have up at the James Hutton Institute, where we can look at different types of different types of hydroponic systems. For example, we can look at ebb and flood, nutrient film technique, and deep water. So here we can compare different systems to see how well they're performing in producing different types of crops in the vertical farm system. At the Stockbridge Technology Centre, then we have the Farming Development Centre. And here we have two identical units where we can compare different temperatures, relative humidities, carbon dioxide concentration, things like that. So here we can look to optimize the different lighting regimes. We can look at different temperatures. We can look at different hydroponic systems and optimizing the way the crops are lit, the wavelengths that are being used to try and optimize not just the quality of the produce, but also to try and make the systems as economically viable as possible. So within these types of systems, then we can look at the different sensors that can be used. We can have automated sensors that can pick up any spores that enter into the system or insects. And we can have sensors looking at volatiles, which may be an indication of crop stress or crop disease. At the University of Warwick, at the Wellesbourne campus, we have the Natural Light Growing Centre. So here we have a novel way of constructing greenhouses, which is shown to be quicker and more efficient than some of the current techniques. So there you can see that it's possible to put the ground foundations in without the need for substantial groundworks. This is much quicker and much cheaper than the traditional system. And the aluminium frame can be put up quickly and uses less aluminium than traditional greenhouses because the ETFE coating is much lighter, of course, than the glass. So there's a novel technique for coating this frame with the ETFE film. And once it's in place, then it can be heated up and it becomes rigid and very weatherproof. So again, similar to the other sites, we can look at different ways of growing the crops, optimizing the temperature and the lighting. One of the things about ETFE that it transmits the full UV light, unlike glass, so we're getting a different type of lighting inside the greenhouse. This offers opportunities for developing varieties that would be better grown in full UV lighting conditions rather than under glass. So we can look at crop breeding and looking at nutrient density of some of the crops that are grown inside that greenhouse. So just to summarize, then if we're looking at CEA in the future, then vertical farming, as we all know, is really taking off. And on the right there, you can see a picture showing an example of a large vertical farm. So we have new ways of constructing some of the CEA facilities. There's the development of automated sensors and also robotics as well. Robotics in terms of treating the crop and harvesting the crop. And one of the ways of making this type of agriculture more sustainable is looking at the location where some of these facilities are constructed. They can be close to energy sources, such as anaerobic digesters, or they can be close to the entry point for the produce into the food supply chain to cut down on the amount of transport required for the different produce. And as we heard earlier, then there's a limit to the amount of farmland that we can have in the world. So optimizing land use is key to this. So we can use brownfield sites for these greenhouses and vertical farms, or we can put them underground as well. And there's a number of vertical farms already being developed in the underground. And finally, we're looking at a circular economy, so there's no waste of anything within the whole growing system. So for example, from anaerobic digesters, then that can be used to fertilize the crops back in the greenhouse, and the haulms for some of the crops after harvest can be used to go back into industry to produce certain chemicals or certain nutrients, so there's no waste of anything at all. So we're looking to develop an economic system that's looking at sustainable use of resources, sustainable ways of growing produce, and producing more food in the UK to make the UK more resilient and more self-sufficient in food in the future. And thank you very much for your attention.
Lovely, thank you, Richard. I didn't realise you had such a widespread geographical locations for the research and development you're doing in the UK. So really good to see that it's not just stuck in one place. So thank you very much, Richard. I'm now going to bring in Alex Giles from Liberty Produce, and hopefully Alex is going to blow my mind a little bit more about what Liberty Produce are doing. So I'll hand over to you now, Alex. Thanks for joining us.
No, thank you, Wendy, and thank you for this opportunity. I'm very glad that Richard's gone first, because I know we've got an expert on this webinar. I am a bit of an accidental AgTech person, so I'm very glad we're going to have someone that, when the difficult questions come later, Wendy, that you give us that can give us an expert answer. But again, thank you for the opportunity. So Liberty, as has been mentioned before, is a startup. We started back in late 2018, and in October of 2019 we opened our first facility up at the James Hutton Research and Development facility, the Future Farming Hub. And if you'll indulge me, a short video on our opening.
Could this be the answer to feeding ever-growing populations around the world? A new facility at the James Hutton Institute uses the latest technology to grow crops inside shipping containers. The work going on here is seen as vital to help the UK maintain crop requirements for the future. But it could also be used in countries where crops consistently fail.
This model, given that it's a container-based system, can be shipped anywhere around the world. It's not reliant on the natural environment at all. It's fully self-contained. We're controlling the environment within it.
This mode of farming looks set to be a growth industry. Stephen McMenemy, STV News.
And I will say, for the sharp-eyed amongst the viewers of this, you'll see the deliberate mistake at about 3 seconds into that video, where you do actually see an insect has got into that facility. He, of course, was hunted down and humanely taken out of the facility afterwards. But as we say, this is a fully equipped state-of-the-art, total controlled environmental agricultural facility supported by CHAP. And what we're concentrating now on in that facility is research and development, and particularly a soft fruit speed breeding program in collaboration with our partners at the James Hutton Institute. So as I mentioned, what we're able to do at the Future Farming Hub is control everything that you would need to do when you talk about advanced farming. So whether that's the touch control system we have, the bespoke LED lighting that we've developed, the ability to put different nutrients into the water system. As Richard mentioned, we have 3 different types of hydroponic growing on the 3 different levels, and then the analysis that we're able to do afterwards. So it really is a full spectrum capability that we're developing up in Dundee. As I mentioned, we're very glad that we've been able to develop 2 different lighting products to support both the Future Farming Hub and to start exports of that technology around the world. A full white spectrum system, fully controllable, and a smart system as well with an integrated app. I'm pleased to say that system has already seen some export success in Canada and in the United States, and we're looking forward in next year to developing those exports further. And we have a 12-channel nutrient control system in this system. It is a probably over-engineered than what you might expect in a commercial growing facility. So you have 12 channels there where you might expect only 2 or 3. But that means that we can have the great ability to do that really advanced research and development for our customers. We've built and are continuing to develop a advanced sensor system into that. We are very pleased that we've had further Innovate UK funding just announced a couple of weeks ago. We'll be developing AI and ML into that facility, hoping to put a 5G connection into there as well. And so the plan by late in 2021 is that we'll feel that this facility will be one of the most advanced, if not the most advanced, vertical farming R&D systems in the world. So some of the ideas of the kind of growing that we're doing, this is some work that's ongoing at the moment for the growing of chives in a vertical farm. That is something that people have found very difficult to do in the past. Our customer base for that particular project has wanted them to be up to 20 centimeters for harvesting. That's what you need in a chive. And we were very pleased that we were able to demonstrate that was something that was very possible to do in a vertical farming environment. And then again, with our partners at the James Hutton, this exciting speed breeding program on blueberries. Again, a really high value crop, something that is in great demand around the world. And we've been able to demonstrate that the germination time can be cut from 10 weeks in a glass house to under 3 weeks in a vertical farming, in our vertical farming system. So the research implications for this is vertical farming has capability beyond microgreens. I mean, this is very much how vertical farming started. People supplying microgreens for the urban environment. It was very successful and continues to be very successful for a number of commercial growers in London and around the world. But what we want to do is go beyond that. We want to push into this propagation idea for fruiting crops. We want to expand our speed breeding programs. That's important, of course, for biodiversity. We want to find out to extend the range of crops that you can grow in a vertical farm, to really extend the boundaries of what's possible. And we hope that a facility like we have up at Dundee can really help with that exercise. And we hope to partner with people further around the world. Thank you very much for your time. I appreciate it.
Thank you, Alex. I didn't realise actually how much innovation and sort of change of direction you guys have gone through since I first met you. So really, really nice to see your development. So as you said, we're going to bring Richard back in now. And I have had some questions, as you would expect, emailed across to me. And I wouldn't mind, obviously, hearing your thoughts about these. So if you're both open to it, my first question, I think probably is one that everybody asks, and everybody will have asked you in turn, is that potential users that are implementing CEA find that it's quite costly. Are there more commercial offerings coming to the market soon? Probably yourself, Richard, will have a good answer on this one.
Yeah, we're looking at new ways of constructing greenhouses, as we saw with the one in Warwick, which is almost a prototype. But that's going to be a way of being able to put up a greenhouse much quicker and much cheaper than the current technique, and also requires a lot less support in terms of aluminium frames and things like that. So we're moving into an era where we've got larger greenhouses that can be put up rapidly and cheaper to run, as well as cheaper to put up.
Fabulous. And to yourself, Alex, many people can obviously see the benefits of CEA in countries where there's poor land quality or critical water supply issues. Do you feel there is a need for this type of farming practice in the UK?
I mean, that's a very good question. You know, what holds vertical farming back at the moment is, you know, you have expensive capex and you do have expensive opex. So I suppose you can approach that in one of two ways. You can obviously work to reduce the opex, and that's something that we're doing particularly in the areas of how you reduce power consumption, whether that's the lighting being the classic aspect there. And the other aspect is how you introduce crops where they are higher value. And so, as I said, at the moment where traditionally the microgreens have been the crop of choice because they're a relatively high value crop, I think moving from that into the pharmaceutical industry and the cosmetics industry, where there are ingredients there that are in great demand. There are ingredients where you clearly need a very secure environment. You need to replicate that perfectly each time that you grow whatever that ingredient might be. Those are the types of area commercially where I think that in the first world, here in the UK and in Europe, where I think you'll see a lot of growth in people building facilities for that.
I think that quite nicely leads on to one that's on my mind. And with that bigger picture in mind, then we see a lot of monoculture farming going on, and it's widespread globally. What place do you see CEA having in increasing that biodiversity? And I think that's probably for both of you. So, Richard, would you like to go first on that one?
Yeah, with CEA, then we can put in a lot of different crops into that system and help to sort of develop new varieties, which can be used both indoors and outdoors. And helping to sort of speed up breeding would enable more sort of polyculture to be done outdoors. So I can see that the two systems, the CEA and the outdoor agriculture, working together really, and helping each other out. There's been quite a move towards IPM with outdoor agriculture. And IPM's been used for a long time for indoor agriculture, CEA, with a lot of pest control that's done using predators and a lot of use of biopesticides. So it's getting away from the reliance on a lot of the synthetic chemicals and fertilizers that have been used in the past. And it's a much more sustainable system, which is going to help biodiversity in the end and reduce the amount of any contaminants leaving the system to contaminate the environment.
Have you anything to add to that, Alex?
Well, I wholeheartedly agree with Richard. It's what we call this hybrid approach. We certainly don't expect farmers to tear down extensive glasshouse systems that they already have. That would be ridiculous. But it's where you can introduce a vertical farming capability at that propagation stage into that hybrid approach. You can imagine in a standard 40-foot container as we have in Scotland, you can have 20,000 blueberry plants at an early stage sitting in that facility, for example. And so you can imagine as you scale that up to a soft fruit farm, you could have some sort of containerized system doing the propagation, and then that going out into the polytunnels or the glass houses afterwards.
So what areas are you seeing the most engagement? Are you getting engagement from the existing farming community? I'll probably ask yourself, Alex, and then the same to Richard, because you're both coming at it from slightly different angles.
Again, that's a really good question. I mean, at the moment, and we're only, we're 18 months into our development as a company. We've seen a lot of growth with big scale commercial growers very interested in these speed breeding ideas. We would like to very much engage with farmers at all levels going forward, because we absolutely see putting vertical farms in urban environments, which has been a bit of a push by people, comes with a lot of challenges of urban planning. But taking vertical farmings and put them on agricultural land, which has already been designated for that, is a much easier proposition. And I think you just need to find, farmers forward thinking, and farmers traditionally have always been looking to improve the environment, to improve how they're doing things. So I don't think that's a hard ask for us to do, but it's engaging with them at all scales going forward, which is very exciting for us.
Lovely. And yourself, Richard?
Yeah, it's amazing how much interest I've heard from farmers who are sort of looking to diversify into things like vertical farming when they don't really know much about it, but they've heard about it and they think that they need to find out more. And some of them have sort of tried their own sort of experimental pilot plant vertical farms. But yeah, farmers are always looking to diversify, aren't they, and move away from some of the traditional crops, and maybe also increase the income that they have from the land available. So I think it's encouraging to see the interest from traditional outdoor farmers in this new technology.
Yeah, I totally agree. So probably the last and closing question, which again, everybody wants to know, whether you know it, I don't know. So I'm going to ask yourself, Richard, firstly, what do you see as the next steps for the industry?
I think as the technology develops, then it's going to become much more automated. At the moment, there's a lot of manual work required in greenhouses, and also in terms of irrigation and fertigation and crop protection. But there's a lot of sensors that we're aware of within CHAP, companies coming to us to talk about them. And that's going to move it forward dramatically in the next few years, and require very little manual input into the way crops are grown. And it'll be done, with automated sensors, robotics going through the crops. So I can see that developing very quickly.
Okay. And for yourself then, Alex, one closing question for yourself then. Who do you see, or who do you believe are the sort of influencers or enablers to help bring all this technology together?
I think it will be some of the very forward-thinking governments in parts of the world where land is at a premium. So you can already see the Singaporean government is heavily investing in this area for very obvious reasons. And you can see governments in the Gulf, particularly the UAE, Qatar, Bahrain, all very land constrained, all operating in very what we regard as austere environments for farming, with the resources to do big things with this. So I think that you'll see those governments, when you want to see large scale facilities, when they make that decision to invest and to encourage companies to come to them and put their technology in, that's where you'll see the big jumps forward in the coming years.
Fabulous. So thank you very much, both of you. I've loved listening to you and obviously getting the answers to some of those pertinent key questions that have been sent in to myself. So I'd like to thank everybody for joining today. And today, as I said, was our first event on controlled environment agriculture. And this was around the role of CEA in the sustainability, which I hope everybody has been a bit more aware of what's going on. The research and development being done by CHAP across the whole of the UK. And again, some of that technology that I didn't even know existed being done by Liberty Produce as well. So if you do want to get in touch with either of the presenters, please do email agritecheaglelabs@barclays.com, and we can share their details and also share any of the slides. Now, what I would like to say is just a great big thank you from myself and from the Eagle Labs AgriTech team to both yourself, Richard, and yourself, Alex. I hope you've enjoyed today, and I look forward to catching up with you in the near future.
Thank you.
Thank you very much.